Evaluation of limits, the F.C.S. method. The F.C.S. method consists of 3 steps: F for factor, C for cancel, and S for substitute. The F.C.S. method is valid for the evaluation of limits of rational functions. Recall that a rational function is a ratio of polynomials. So, a rational function is a quotient where both the numerator and denominator consist of sums and differences of constant multiples of whole number powers of the variable. Let's illustrate the F.C.S. method with some examples. Consider the limit as x approaches 1 of x squared minus 1 divided by x minus 1. Notice that this is a limit of a rational function. We cannot initially evaluate the limit by substituting in x equals 1, since this would lead to division by 0. We must apply the F.C.S. method. We want to respect the mathematical notation and clearly communicate our solution. First, we are evaluating a limit, so we must reflect this in our written solution. So, we start by writing an equal sign and writing the fact that this is a limit as x approaches 1. We want to factor both the numerator and the denominator. The denominator is already factored, so we simply rewrite it. Since the numerator is the difference of 2 perfect squares, namely x squared and 1 squared, we can factor it as x minus 1 times x plus 1. Now for the cancellation. Since x minus 1 is a factor of both the numerator and the denominator, we can cancel these factors. We write the equal sign and the limit as x approaches 1. The cancellation leads to the new function x plus 1. This step is justified by the fact that we are now considering the limit of a new function x plus 1. But since this function differs from the old function x squared minus 1 divided by x minus 1 only at x equals 1, the limit of the new function is the same as the limit of the old function. That is, the limits are the same even though the functions are different. Now for the final step of F.C.S. We now need to evaluate a limit of a polynomial. Since the limits of polynomials can be evaluated by substitution, we now substitute x equals 1. Simplifying, we get the final answer. The limit is 2, and we put a square around the final answer to be clear that this is the answer to the question asked. Here, we see each of the steps of F.C.S. Factor, cancel, and substitute.
Let's do another. Consider the limit as x approaches 3 of x squared minus 5x plus 6 divided by x squared minus 9. Again, this is a limit of a rational function, and so we apply the F.C.S. method. First, we factor the numerator and denominator. Since this is a limit, we write the equal sign and the limit symbols. The denominator is the difference of 2 perfect squares, namely x squared and 3 squared. Therefore, it factors as x plus 3 times x minus 3. To factor the numerator, we need 2 numbers, m and n, such that m plus n equals negative 5 and m times n equals 6. We determine m and n by considering the factors of 6. A moment of reflection reveals that the desired values of m and n are m equals negative 3 and n equals negative 2. Therefore, the numerator factors as x minus 3 times x minus 2. We can now cancel the common factor x minus 3. We write the equal sign and limit information, and the cancellation leads to x minus 2 divided by x plus 3. Since x minus 2 divided by x plus 3 is a rational function, we can evaluate the limit by substitution. We put a box around the final answer for emphasis.
The F.C.S. method works for functions other than rational functions. We illustrate this with two examples. Consider the limit as x approaches 0 of 1 divided by x plus 3 minus 1 divided by 3, all divided by x. Strictly speaking, this is a limit of a function which does not appear to be a rational function. The function is in the form of a compound fraction. In fact, this is the key to solving the limit. As always, we write the equal sign and the limit information at every step. Since division by x is equivalent to multiplication by 1 over x, we rewrite the function as follows. Notice that if we multiply this out, we see that this function actually is a rational function. We continue to try to simplify by getting a common denominator for the 1 divided by x plus 3 minus 1 divided by 3 part of the function. The common denominator is the product of x plus 3 and 3. So, we multiply 1 divided by x plus 3 by 3 divided by 3, and we multiply 1 divided by 3 by x plus 3 divided by x plus 3. We now carry out the multiplication. This allows us to combine the functions. We distribute the negative sign in the numerator. Next, we simplify the numerator, and this leads to the factoring of the numerator. We cancel the factor x in the numerator and denominator. We have now removed the factor of x in the denominator, which, up to this point, stopped us from substituting in x equals 0. We are now ready for the last step of F.C.S. Finally, we substitute in x equals 0. Simplifying and putting a square around the result, we see that the answer is -1/9. We now consider a limit which involves a function which is definitely not a rational function. This means that accomplishing the factoring is a bit tricky. We start by multiplying by the so-called conjugate of the numerator divided by itself. The validity of this cannot be questioned since we have simply multiplied by 1. However, the motivation of this may be unclear at this stage. As we will see, this step takes us in the desired direction. That is, it will allow us to factor the numerator. Now we perform some algebra. The denominator is already factored, so we don't modify it. Now, we start to see the reason for multiplying by the conjugate. Multiplying out in the numerator introduces the square of the first term minus the square of the second term. Again, we are happy with the denominator since we have isolated the factor x plus 4. And it is this factor which must be canceled in order to complete the F.C.S. method. Performing the squaring in the numerator reveals the real reason for multiplying by the conjugate. It eliminates the square root in the numerator and will yield an expression which we can factor. We distribute the negative sign. Next, simplify the numerator. The numerator can now be factored. Since it is a difference of two squares, namely 4 squared and x squared, we can factor the numerator as 4 minus x times 4 plus x. Now that the numerator and denominator are both factored, we are in the position to cancel the factors of 4 plus x. Simplifying, we see that we are now ready for the last step of F.C.S. Notice that substitution does not lead to any forbidden algebraic operations, such as division by 0. Hence, we substitute in x equals -4. We simplify, and the final answer is 4/5. The factor cancel substitute method works for rational functions, compound fractions, and functions which can be rationalized. Such functions involve square roots. But the F.C.S. method does not work for everything. For example, consider the limit as x approaches 0 of sin x divided by x. Later, we will show that this limit is 1. However, we cannot factor an x out of sin x and perform the necessary cancellation. So, there must be some other techniques of evaluating limits.